And welcome to this session. We are excited to have you. My name is Brett Shaw. I'm from CrowdStrike. I'm on our product marketing team, and I specifically have coverage and responsibility over our cloud security solutions. And that's what we'll be talking about today, is securing your container environment with CrowdStrike Falcon security. And joining me today...
Hi, I'm Rob Solomon, Senior Solution Architect at CrowdStrike, working with the AWS Partnership, formerly an AWS Solution Architect.
Awesome. So let's go ahead and get right into it and talk about everything that we're going to be covering today. So we're going to talk about the different cloud and container challenges that we have out there, the threat landscape, the different challenges that organizations are facing today as they're building out in the cloud, and highlight some best practices in terms of how to protect those containers, protect your cloud environment. We'll go through an in-depth view of how CrowdStrike helps with this specifically, what different solutions we have, even integrations with AWS, as y'all are users of AWS, and then take you in through a demo, and again, how our GitOps and DevSecOps architectures are with Falcon Cloud Security, and then we'll go through next steps. So with that said, let's go ahead and jump into what we're seeing in terms of the threat landscape out there today. Now, regardless of where y'all are at in your cloud journey, whether you're just beginning that and starting your migration, whether you've already made those steps and have built out a multi-cloud and hybrid environment, or if you've already cloud native, right? As you advance in this, it's in every phase there's new technologies, whether that's virtual machines, whether that's containers or serverless functions. And with every new environment and every phase and every technology that's deployed, there are new threats. It's inevitable. There's new threats, and adversaries are taking advantage of this. And with these new technologies, though, there are multiple and different solutions that you have to deploy to secure them. And you can see that up here, whether that's, IAC scanning or serverless security or cloud storage security, whatever it might be, there's new technologies. But with all of this, there's complexity. There's different tools that you're having to manage, not only on the technology side, but also the security side. And you've got to become an expert in all of these. And a lot of times that brings the challenges of speed. You're not able to work as fast. And again, it leaves these gaps for these adversaries to target cloud environments. And in fact, you can see up here, just this last year, there was a 75% increase in cloud exploitation. And again, a lot of times, these adversaries have more expertise in working in the cloud than a lot of these enterprise organizations that are deploying. That's their sole focus, is understanding how to get through these gaps of these different security solutions and find out how to exploit these cloud environments.
Well, and don't forget, Brett, there's all of the data from all these different solutions, all of the event data and detection data. It's the customer's responsibility to knit that all together, to aggregate, consolidate that data.
Oh yeah, and that's a great point, Rob. And again, it just brings the complexity of all of that, and understanding that it's just, again, a challenge that customers face today, organizations face today. And another stat that you see up there, the 110% increase in cloud-conscious threat actors. This is where we have found in our research that these adversaries are using cloud-specific tactics, techniques, and procedures. Again, they're getting more sophisticated and they're getting smarter. But not only that, they're also getting faster. As you can see here, the average breakout time is 62 minutes. And when I say breakout time, that's the time from initial access to lateral movement. This has dropped from 84 minutes just this last year. And one of the more fascinating things that I think is, I've been talking for about 5 minutes now. The fastest recorded time of breakout time that we recorded was just over 2 minutes. It was 2 minutes and 7 seconds. So these adversaries are working very, very fast. They're able to get in and move laterally a lot faster than a lot of defenders have the knowledge of what's even going on. And so as we look at this and the anatomy of an attack, it's really these adversaries, they're gaining access. They're doing some looking around. They're discovering. They are then moving laterally. They're looking for different targets, maybe the high-profile assets that they can go after. They're hiding their tracks, and then they're causing the impact, whether that's dropping ransomware. And you can see here, this is an illustration of something that we saw. It took about 39 minutes for this adversary to come in and break into an account just simply using a brute force attack. From there, they dropped a legitimate file, and the victim here was an environment, and they didn't have the quarantine policy on, and so it wasn't able to quarantine what was happening. From there, they dropped 2 discovery tools to understand, again, better where they're at in the environment. And then they tried to drop some ransomware, but it never ran because Falcon was installed in here. We saw what was going on. The adversary saw that Falcon was installed in this environment, and they didn't even decide to run the ransomware. Our Overwatch team came in and helped and notified the customer of what was going on and fixed the issue, remediated it, and they isolated the host itself. And you can see the power and how quick an organization, again, has to be. But not only that, but as we're talking about this today and building out a cloud environment, this is just one facet. But as you start to build out your container environment, this problem really amplifies it. Right, Rob?
Yeah. So we're just trying to set the stage here for what exactly are the challenges that you're faced when you move into a cloud environment. And today we're talking about container security. So what are the additional challenges when you're working in a container environment? So just to get a sense of the scale, and this is something that probably everyone here knows, back in the old days, it was one operating system per bare metal. And VMs were developed to take better advantage of those resources, to divvy them up into virtual machines, and you could run several on a given bare metal instance. But then when you think about containers, you're talking about a whole new level of scale. And operating in that level, there are, again, specific challenges that have to be addressed in order to be able to detect and respond to these sophisticated, these fast attacks. So you have this level of scale. You have pods that are being deployed in response to higher utilization, being torn down. So there's a lot of resource churn. And how do you track what is actually running in your environment at any given time? So just maintaining that level of visibility in that dynamic environment. And of course, one of the things, and we're going to look at a few more of them, but one of the big challenges in running in a Kubernetes environment is making sure that your pods, that the pod permissions and Linux capabilities do not allow it, if that pod is compromised, to move into the host and to be able to start accessing other services elsewhere. So AWS publishes an EKS best practices security guide that I think really gives you a sense of the scope and scale of what needs to be addressed to secure your container environment. So it really all starts with that container image, which represents package application code and libraries and some configuration. All of that's packaged together in your container image. And we're going to talk more about that in the demo in a few minutes. But it's important to make sure that those container images don't have vulnerabilities and misconfigurations. So that's really where it all starts. And then, like I said, the pods themselves, as they're configured and deployed, to make sure that they don't have, they're not misconfigured, they don't have the ability to take advantage of unnecessary elevated permissions. Making sure that any secrets that are required, data in those pods needs to be encrypted, access controls, who can access your cluster environment, what identity and what access each pod has to access other microservices or AWS services, and of course, critically, that runtime security. I've heard a lot of people, ask the question, why do we need runtime security in a container cluster environment when you have these ephemeral resources that are being stood up and torn down? Nobody's going to be able to get a foothold long enough to have any impact. And I think that this acceleration of these attacks means that those pods don't have to be around very long. And I think that even in that ephemeral, highly dynamic environment, that just a few minutes is all that's required. So that, the cluster itself, the network attributes of the cluster, whether traffic is encrypted in transit, the overarching network of tying everything together, whether you're running multiple workloads, being able to know what's happening in your cluster, those detective controls, and being prepared to take action if there is a problem in your environment, that you have the telemetry to be able to do an investigation and mitigation, and finally, having the visibility in your cluster as a whole to make sure that you are abiding by configuration and compliance best practices. So these are all of the different layers that you have to address in your container environment. And these are all things, these are all components of Falcon Cloud Security.
Yep. And awesome. I'll talk about this, but if you're not familiar with CrowdStrike and what our mission is, at its core and what we really believe in is stopping breaches. And we do this, as Rob alluded to, with a unified platform that's built on this single agent. And so we sit across many vectors. We're collecting telemetry from endpoints, from cloud workloads, identity, and third-party sources. And everything that we see is we're correlating and understanding at this data layer, understanding the behaviors of the adversaries, understanding how assets are connected, understanding everything that we need to from an intelligence standpoint. And all of this is shared with our customers. And we're going to be focusing on the cloud security module that you can see here on the left-hand side. But again, just wanted to paint the picture of why CrowdStrike is so effective in stopping breaches today, and that is because of our unified platform. And so with that said, as we talk about Falcon Cloud Security and what it entails today, I talked about those disparate solutions at the first of the presentation. With Falcon Cloud Security, we can bring all those under a single platform to manage everything that you have and to see and detect what's running and have that visibility. So detecting threats in real time, understanding before you deploy, and I'll get into this, before you deploy, are there misconfigurations? Are there certain things that we need to address before we ship what's going on? Understanding the different applications that are out there as you're building in the cloud, how they're all interconnected, and really prioritizing cloud and application risk that you have so you can respond quickly. So as I mentioned before, being faster than the adversary, being faster than that 2 minutes and 7 seconds. And so we really break this down into 3 pillars. And Rob talked about this from pre-runtime. Again, you've heard of shift left. This is where before we ever deploy anything, understanding, are the images okay from doing image assessment? We're doing infrastructure as code. Is everything that we're deploying from that standpoint okay and secure and okay to go out into production with? And then we're moving on into runtime. Again, Rob talked about this and alluded to this, but understanding as you're building out and these resources are running in the cloud, being able to run our sensor on there and detect what's going on. Understand, are there vulnerabilities? Are certain assets being targeted? And finally, the comprehensive visibility across your entire cloud estate, understanding what managed assets you have out there, or if there's unmanaged assets that you didn't know about. Having the visibility of compliance to certain security standards and frameworks that we have. Understanding who has access to what in terms of identity access and entitlement management. And so this is really at the core of what we do with Falcon Cloud Security. And more specifically, as we're here to talk about Kubernetes and container security, let's take a little bit deeper dive into that, Rob.
So in this diagram, what you see is a component that focuses on image security. We're not even addressing runtime security, so and we'll talk about that in a minute so you understand how the runtime piece comes in. But the demo today that we're going to be running through has to do with image security and setting policy. So, if you think about the pre-runtime, the runtime environment, just in terms of that software development lifecycle, starting in the top left, image vulnerability analysis tool. We have a number of different ways that we perform image assessment, really mapping to those different stages. So that first stage, that analysis tool, is something that would run locally on a developer IDE, so that as the developer is building code, creating a test container image, they can run it against this analysis tool to get that fast feedback that they can then sort of roll right back into their code to make those improvements, come up with a non-vulnerable package, and lock down some of those misconfigurations. All of that data in that tool stays local. That is not shared with the actual platform. And again, it's intended for that fast feedback loop. But then once that code is checked into the repository and is built as a container, then the container image assessment can be built into your pipeline so that the job is automatically triggered. We do the assessment. We find whether there are any stored secrets or, again, vulnerabilities, misconfigurations. And that data is sent back into the Falcon platform. And we're going to come back to that in a minute. Now, this dynamic container analysis is something that you might do on occasion, to take a container image and do a deep dive to see what exactly the behavior is, because it's not all going to appear in the container image itself. It's going to come through in the behavior. So with dynamic container analysis is something that you would select for a particular container image, and it would upload into a sandbox environment where it can be detonated and the various behavior and network connections it might make, let's say, to a malicious IP, actions it might be trying to take on the host OS, to give you insight about whether this image is safe or not, because sometimes you're pulling that image down from a partner or someone in your supply chain, and you want to make sure that it's secure before you move it into production environment. And that's all on the pre-runtime side. Then in the runtime environment, we have that same quality of image assessment as in pipeline scanning. We do registry scanning. Now, why is this important, right? You've gone through pipeline scanning. You find that this image is clean. It doesn't have any vulnerabilities. Now it's running in production. Why do you have to be doing continuous registry scanning? Well, people are discovering new vulnerabilities all the time, and you're going to want to know if something that's actually running in production, if a new vulnerability has been discovered. So that background registry scanning will accomplish that. And we support 16 different registries that you can connect the Falcon platform to do that automatic assessment. We also, if your registry is not one of those 16, or for whatever reason you don't want to or can't configure registry scanning, we have something called image assessment at runtime, where you have an actual deployment and a pod that runs inside of your cluster that is doing that assessment of other running container images during runtime. And then finally, we have a Kubernetes admission controller that and we'll look at that in a second, that you're able to actually create policies about whether to alert or whether to prevent the deployment of particular vulnerable containers. Our Kubernetes admission controller is essentially a webhook for the admission controller architecture of Kubernetes. So if you think about what the end-to-end process would be, a request to create a pod, to schedule a pod on a resource is sent to the Kubernetes API server. It goes through a number of steps, including authenticating that particular user who's issuing the request has the privileges to take those actions. And ultimately, and I passed over the mutating admission controller, this is where we would inject a sidecar container sensor in a Fargate environment. That would happen through the mutating admission controller. But then finally, that validating admission controller, can this particular command be run in this environment? Is it allowed? And that's where our Falcon Kubernetes admission controller is invoked. The image assessment policy is assessed, and then if it passes, then that command is persisted to the key value etcd. So just to see how it would work in real life, first that image is scanned in one of those methods that we just looked at. That assessment has findings. Let's say 20 critical CVEs, 7 misconfigs, and 3 privilege escalation risks. The policy that, and you will see how you can create policy. Let's say create a policy that is going to block on critical CVEs. So that container image is then blocked from being deployed in production.
Well, hop off stage while you go through this
All right.
part.
So we're going to see what it would look like in real life. So here's an image of ECR. You can see there are 4 different image repos in this particular registry. You would set up the registry scanning inside of the Falcon console. Right here, it gives you a list of all the different registries that we support. And once you set that up, you have a dashboard that will give you an overall status. Is the connection healthy? Are you scanning images? And what registries have you actually registered with the Falcon platform? So you see that in the initial. And then you can pivot to the overall image vulnerabilities dashboard, where you can get a high-level look on how many CVEs of different severities, how many images are being scanned, and this one pane, you would continue to scroll, and it gives you kind of a top 10 CVEs, top 10 criticals, different operating systems that are represented by your container images. And you can click into any of those panes to pivot into more detail about any of those particular metrics. In this case, we've pivoted into looking at the specific images that we're scanning from the specific repos and how many vulnerabilities, detections, and so on. And you can see on that top line, and I've filtered. You can see at the top, I've filtered in one of the particular registries, Web DVWA. Some of you might recognize as a testing container. It stands for Damn Vulnerable Web App. And it automatically has these vulnerabilities and misconfigs so you can test your environment against them. So in this case, it found many vulnerabilities, and we can click into that to get more information. So now we're looking at one particular version of that image. We can see summary information. It's been assessed. There's known issues. It's not running in production right now. And you can see in the lower left, how many different detections are in this container. And if I scroll down a little bit more, I can see how many vulnerabilities. 306 critical and high, and 549 total vulnerabilities. And you can see in my filter tab that I'm filtering for just critical and high. And you can see next to vulnerabilities, 306. That is a lot of vulnerabilities for your operations team to have to now go and mitigate. Now, the Falcon platform has something called Expert AI. Because all vulnerabilities, even though the CVE score might say critical, the Falcon platform is looking at the entire environment and contextual data to decide what is actually critical, what is actually high priority, based upon what is the likelihood in your environment that this container image is going to be exploited. Is there a published exploit in the wild? Is it being actively exploited? So we reassess the severity so your operations team can focus on the top priorities. So if we pivot to that expert rating, looking at critical and high, you can see there's only 12. So this greatly reduces the level of effort for you to prioritize reducing risk in your environment quickly. Now, pivoting to the policy engine, there's two components of that. There's the image assessment policies. You can see that we have one is disabled, one is the registry assessment is what we're looking at right now, just the findings from our background registry assessment. And you can set parameters like what is the level of severity of the vulnerabilities we're looking at, what different kinds of vulnerabilities we're assessing for that we're creating policy around. And we're also here saying which particular repos are we scoping into this particular policy. So then we go back, we save all that, we go back to image policies, and we click over to our admission controller policy. Now, I have a few different. Obviously, there's always the default that captures everything, but I want to direct your attention to the first two. The first is image prevent, and the second is indicator of misconfiguration alert only. So you can see they're all enabled, and they will, whichever matches first, processing stops at the first match. So the first one's going to be prevent the deployment of an image. When you look at the policy as a whole, you can scope it to specific namespaces or pod or service labels. And you can also decide how you're going to handle specific misconfigurations that are identified in the assessment. What we have here is they're all disabled except for two. The workload is in the default namespace if you decide that that is something you do not want to encourage. Obviously, that's taking the easy way out, and we don't want to do that. We want to make sure everything is namespaced. And then a container that has too many Linux capabilities, and there's a risk of privilege, unauthorized privilege elevation, we're going to alert on that also. We're not going to block on the misconfigurations. We're just going to alert. We are going to block, prevent on image assessment policies. So within the Kubernetes admission controller, we are enabling image assessment metrics to be assessed by the policy. So, okay, we're ready to go. Here we are at a command line. We're going to just see what's running right now. What's the steady state? So we have a web app. This is not the web DVWA. This is just a web app that is currently running. Oh, it is running in the default namespace. For those of you who are looking at the details, forget about that for a second. That was already running before I created the policy. So we're going to create a deployment, and obviously a deployment is going to it's going to deploy a defined number of replicas, replica pods in your environment. We've got one replica, and we're looking at that web DVWA image in that repo. We try to run it. What happens? We get the 2 warnings. Okay, what are the warnings? Running with many capabilities and create in default namespace. So we're just alerting there, but then the error condition failed to create deployment, admission webhook, forbidden because image assessment reported vulnerabilities for that image, critical vulnerabilities. So that policy does block the deployment. Now we're going to check that, get pods, just to confirm no new pods have been deployed in this environment. Great. Now we're going to pivot back. We're going to disable that first policy, which we've done here, so we're not going to prevent images anymore, just to show you how that assessment engine is working. So we're going to go back and try that deployment again. This time, we have 10 different warnings, and I didn't... Did I show you? Yeah, I didn't show you the specifics of that, but what I did in the other one is I removed the prevent, and all I'm doing is alerting on many different misconfigurations, right? So we got that warning, and you could see at the bottom the deployment was actually created. And if I do a check, kubectl get pods, you could see that vulnerable web app was actually deployed because I did not set the prevention policy. Now, how does this all work in terms of deployment? Again, we talked before about you're running at scale. Every single time you deploy a new pod or deployment, you're not separately taking an action to deploy your container protection, or even your cloud cloud security posture management. All of that has to be set up in advance. You know, one of the ways that we are doing that to make it easy for customers to deploy their cloud security in a multi-account environment is to work with the landing zone, to work with AWS organizations or control tower using CloudFormation stack sets so that for every new account, that stack set will deploy, register the account with the Falcon platform for scanning for misconfigurations and ingesting CloudTrail events through EventBridge to get a near real-time detection of suspicious information that's happening in the cloud control plane layer. You deploy that AWS built-in template, for those of you who have heard of the AWS built-in program, which is designed for partners with multi-account operation and security solutions. Makes it really easy to deploy that protection. And the way it works, again, is not just that cloud security posture management, but you can use the SSM, Systems Manager, distributor package that we have published in all commercial environments to create an automation that will deploy the sensor to every new EC2 instance as it's created, and to deploy the container protection that we just talked about, not the pipelines, obviously, that's going to be bespoke, but the registry scanning and deploying, and we're going to look in just a second about what is deployed, but to deploy all that protection with that one ABI template as you're creating your landing zone. You do it once. You don't have to rerun this for every new account. That all happens in the background. So again, making it easy, making your security deployment scale automatically and deploy automatically as you grow in the cloud is essential to make sure that you are covered and secure as you grow in your cloud journey. Now, one of the best practices with Kubernetes and in general with infrastructure as code is to use GitOps. Again, DevSecOps, shifting left. With GitOps, you're talking about having that single source of truth in your source code repository where any changes made will automatically trigger a set of automated actions. So we already deployed, we already built our pipeline, our scanning pipelines, where we can scan container images. We can also scan infrastructure as code templates. And we also have our cloud security posture management already deployed before even any services are running. So we create a new infrastructure as code template, CloudFormation, Terraform, Ansible, what have you. We check that into the Git repository, and we have built a pipeline using AWS Code Pipeline, which is used for building GitOps workflows. Code Pipeline is monitoring the repo. When there's a change, Code Pipeline will trigger the build job that you have associated with that particular job. That code build will set off that infrastructure as code pipeline scanning. Again, we're looking for best practices. We're looking for potential vulnerabilities. If you deploy that infrastructure as code to build AWS services, we want to make sure that you're building the services securely. If it succeeds, then it passes to the next step in your build pipeline. It builds AWS services, in this case, including EKS. Immediately, Cloud Security Posture Management, because of an exchange of IAM cross-account roles, immediately starts scanning your environment, looking at your services for misconfigurations. At the same time, any suspicious, actually all activity that comes through CloudTrail is being assessed for any suspicious behavior. Now, we use EventBridge in this case. We're not reading the trail after it's written to S3. Like, why aren't we doing that? Have you ever timed that? 5 minutes at best, maybe 10, 15 minutes. So by using EventBridge in this case, that telemetry stream that is destined for S3 coming through CloudTrail, before it's even written, comes right through EventBridge, goes right over to our platform, also running on AWS. So in near real time, we're able to make that assessment about whether there is malicious behavior happening in your environment. Now, like I said, with the ABI template, you deploy your protection even before the resources are in place. So as soon as those resources are built, that will trigger an action again through EventBridge. It will trigger an action to deploy your container protection. You don't even have to take any additional action. Now, pivoting to the application code part, you have a developer building container code and then checks it into the Git repo, which sets off a build job that creates a container using a Docker file, and then sends that up to pre-runtime pipeline scanning. Again, if it passes, it will be pushed to ECR and then deployed into ECS, where EKS protection that has already been deployed is immediately starting to scan your environment. And here's what it looks like if we sort of dig into it. We deploy our Kubernetes protection using Kubernetes native tools. So we want to make it really, really easy and transparent based upon your existing cluster operational practices. So using Kubernetes operator or Helm chart, whatever your flavor is, you deploy that ahead of time. And for ECS worker node, EC2 worker nodes, we deploy as a daemon set, so that for each new worker node that's deployed in order to handle scaling and capacity, we deploy a single pod using, again, the Kubernetes daemon set resource. And in the case of Fargate, we use the mutating admission controller to inject a sidecar into each Fargate pod. Again, the benefit using that native tooling, we are providing runtime protection. In the daemon set, that single pod is protecting all of the pods and the host node. It has those privileges to be able to not just scan for activity and to detect threats and attacks, but to actually stop them in place. If you've seen my other video, or you were here last year, you would have seen me sort of go through an actual attack scenario where we deploy a vulnerable container in an EKS environment that's open to the internet. We attack that vulnerability, create a reverse shell, and start deploying an attack and moving laterally. And what we see is that when you pivot to the Falcon platform, we identify that this is an attack in progress and we stop it automatically. Again, at scale, having information about a problem is great, but it's not scalable. At this massive scale, you're not going to be able to respond to all these attacks. So it's really it's critical that your security controls are able to take independent action when they identify that there's an attack in progress. So we also scan for container drift, and we can detect it and alert, or we can actually prevent things like a container that's been deployed, a pod that's been deployed, pulling down packages from the internet and running executables. You can prevent that from happening. And we talked about the pod admission, the admission controller policies. We have a lab that you can build yourself. It's actually going to be in Workshop Studio very soon. If you're in a workshop led by AWS or CrowdStrike, you will probably use that environment. If you're already a customer, you can run a trial and you can create an API key to build this environment. Or if you're self-starting, within a couple of months, we're going to have trials that will give you a license for 15 days that will enable you to build this environment. What I was just describing in terms of launching an attack and seeing what happens under the covers. And the AWS built-in guide, you can get more information about that. If you forget about this, where this is, you can go to Marketplace, AWS Marketplace, Falcon Cloud Security. There's a link to the AWS built-in guide and template and directions and everything. So check it out. Brett? Brett's going to talk to you a little bit about you're talking about this slide,
yeah,
right?
I say this is great. Right. So great stuff, Rob. Now, as you can see, Rob went through quite a few things and showed us the capabilities of Falcon Cloud Security and how CrowdStrike can protect your container environment. And his great team actually is building all of these integrations that we have, and has done a great job in terms of supporting AWS. At the beginning, I mentioned how well, I don't know if I mentioned this, but we're a great partner with AWS, and we're continuing to grow with them and build with them and make sure that we're securing as you're innovating and building and scaling, just as Rob had mentioned, from that pre-runtime, pre-deployment to runtime to your cloud posture, and even that visibility. And so again, this is a comprehensive view of the integrations we have, and obviously what Rob talked about as well. But as we've seen people and organizations and customers run Falcon Cloud Security in their environment, we've seen a great return on investment for them. On average, as you can see here, our Falcon Cloud Security customers expect to save money, to save time, and be more effective, to become faster and respond to those different threats and detect those threats and be more effective with Falcon Cloud Security. And here's a great quote that I love from the CISO at Geisinger that you can read here, but really appreciates how we're able to help protect his AWS environment. And not only that, we do have third-party and analyst backing. It's not just us saying, hey, we are effective, but you can see here that we've been a leader with Gartner in the endpoint front, and then just recently, just a few months ago, Forrester released a cloud workload security wave where we're a leader in that as well. And we've gone through tests with these third parties as well. We scored 100% on the MITRE Ingenuity attack evaluation, and it really, again, speaks volumes to how we're able to protect organizations today. And so with that said, you can try this on your own. We have what's called a cloud security health check, and it's a no cost, no obligation. It's free to you to run. And I've got a QR code for you on the next page. But what this is basically we can deploy Falcon Cloud Security. We can look and give you visibility into all of your resources. You can talk with one of our experts to identify those risks across your cloud environment. And not only that, but as you do this, there is a $1,000 AWS credit that you can get upon completion of this. And so, Rob, anything you want to add to that?
Well, just that $1,000 service credit we offer in partnership with AWS, and it's just for going through the security health check. Really the question, like, this is a way to get your hands on the platform to assess your overall risk. We're using cloud security posture management here. And really the question to ask is, how confident are you in your current cloud security?
So I'll flash this up here. Feel free to take a picture of this, and then you can use another phone or camera later on to scan all these codes. And I'll go through each of one of these. So that first one on the left, the CrowdStrike 2024 Global Threat Report, is where I pulled those stats that I talked about at the very first of our presentation. It's an awesome report. It goes more into just the cloud security that I talked, the cloud threat landscape that I talked about. The next one is our Falcon Hands-On Labs, which is a weekly lab that you can join where you can see CrowdStrike in action, not just Falcon Cloud Security, but all of our modules. That QR code.
And you can actually get your hands on, like, it's a weekly lab that you register for, and you actually have your hands on a lab environment, and you can kick the tires a little bit.
Yes. Yep. And then that third one, the cloud security health check, that will take you to the page where you can fill it out and get in the tracker, so our team can reach out to you to start that health check. And then finally, Rob mentioned this in his demo, that we've got a 15-day free trial as well for this.
Yeah, so what I would say about the free trial is super easy to get started. Again, you can get your hands on the platform if you're not already a CrowdStrike customer, and you can add modules. CrowdStrike has how many modules? Like 22 modules. So you start the trial, and then we have an internal marketplace. You can go in there and you can add identity protection or vulnerability management or cloud security posture management. We don't have the container part yet. Again, that's coming in a couple of months.
Cool. Awesome. Thanks, Rob. So with that said, again, we appreciate your time.
Thanks, everybody.